for this statement right here, a number x is decreased by 13 is less than or equal to 39. So a number x decreased by 13. Decreased means subtract. So x decreased by 13, wouldn't that be one of these two? A number x decreased by 13, and then less than or equal to. Which one of these is less than or equal to? Isn't it that one? 39? So bam. There's my answer. It's kind of, just got to read it carefully and be careful. Know what like decreased means, less than or equal to means. Just be careful. All right, a shopkeeper has X kilograms of tea in stock. He sells this many. So if you sell, isn't that taking away from what you have? So if you look at these, if he has X, they all start with X, right? But he sells 15, do you know right off that this and this are not possible? Because you're selling, you're getting rid of 15. And then he receives a new shipment of 2y. So receiving means he adds to it, correct? So would he be adding 2y after that? So there's my answer. All right, divide a number by 5. So let's say n is the number. Which of these is a number divided by 5? Does that one? Can I cross out C? Okay, this one right here is divide by 5. But let's look at the rest of the question. It says divide by 5 and add 4 to the result. So which one of these, when you divide by 5, you added 4 to the result? Well, isn't this one right here? No, because you added 4 before you divided. This you added 9, correct? So wouldn't this be the answer? Because you divided by 5, you added 4 to the result, and that is 9, equal to 9. The answer is 9. So there we go. All right, local bookstore. The books that are normal and cost B dollars are on sale for $10 off the normal price. What's it cost if you bought 3? Well, don't you first have to take $10 off? Okay, so right off, can I cross off these two? Because I don't add $10 to it. I took $10 off. But the question is, which one is it? Well, this right here is saying you sold 3 at full price, then took $10 off. Isn't this one saying you take $10 off of the price, and then the parentheses say make 3 of those? So are you okay that C is the answer? Because you have to take the $10 off first, then multiply by 3 because you sold 3 of them, or bought. It depends on the problem. A systems of equation, these are systems of equations, 2 equations. Now, it says the sum of the 2 numbers is 10. Isn't the word is mean equal? Yes. And doesn't sum mean plus?
Yes.
Okay, so could I cross out this one because that's the product is 10? Isn't that another product is 10? So isn't it one of these two? Is that right so far? But it says next, it says one number is 5 times the other. Well, isn't this one saying one number is 5 more than the other? Isn't this one saying times? So isn't that the answer? Because this one's more. That's not right there. We're looking for this one right here, 5 times. You have to understand times means multiply. For this particular problem, you first need to put 2 for n and 1/2 for x. So you're going to get 2, 4 minus 1/2. That's the first situation. Now, next, I have to combine this first. Now, hopefully some of you could look at this and know that's 3.5. Most likely might struggle. So first thing, can I put a 1 underneath there? Multiply up, and what do you get? 8. Okay, multiply up, you get 1. And isn't that a minus between? And when I multiply across, don't I get 2? Does that equal 7 over 2? So I now have 2 times 7 over 2. Could I put a 1 right there? Now there's 2 options. you can multiply straight across and get 14 over 2. Remember, you just multiply straight across, which is what? If you multiply straight over, you get 14 over 2, which is 7. Now, could you also technically cancel these right here? You're also allowed to cancel those 2 2's and get 7 that way. So first you got to do this, then you got to multiply by 2, and your answer is 7. We're going to put 3 for H and 4 for K. So that's going to be 3 for H, 4 for K, plus 4 divided by 2 minus 2. This right here is 12. Okay, so rewrite the whole thing around it. It's kind of important to write the whole thing around it. 12 plus 4 is 16. And this right here is 8. So this would be 8 minus 2, which is 6. In order to find this value, x is 7, so you're going to put 7 right there and then do order of operations. Remember, order of operations is PEMDAS. And remember, multiply, divide, you go left to right, and add, subtract, you go left to right. So let's first take care of parentheses. So let's take care of this parenthesis and this one. But don't have to put a 7 right there. So inside this parenthesis, aren't you going to square first and then add 3? So what's 3 plus 25? That's 28. Okay? You have divided by 4. And then what's right here? What's 7 plus 1? That's 8. Now, do I need these parentheses anymore? No, this is a number inside, so you kind of can drop them, unless they're used as multiplication. So now we multiply divide from left to right. So let's multiply divide. What's 28 divided by 4?
7.
Hopefully you know that's 7. And you got the minus 8. So which answer is 7 minus 8?
B.
B. Alright, 3 hours. After 3 hours of travel, car A is how many kilometers ahead of car B? So when we're going 3 hours of travel, do you understand we're looking at this right here, 3 hours. Do you see the word out, time right here? So we're looking right there under 3. And we're looking at these two values. Alright? So what's the difference there? How far away? This is A, this is B. The question is basically, how much higher is this than this? Now you might think, oh, 2, and go with A. But don't you have to go over here and look at these numbers? When you look at these numbers, isn't that from 40 to 60? So if I'm going from 40 to 60, isn't that going to be 20? You got to be very careful. You first got to find time of 3, then you got to see the distance between the two, and see that's 2 increments, and you go over here and notice 40 to 60 is a difference of 20. Be very careful, look at the graph carefully, just read, you can get it. The cost of a long distance call charged by the 2 companies. You have company A, which is this line, and you have company B, which is this line. Are you okay that this is minutes? How many minutes? And are you okay that this one's how much it costs? It's saying company A is less expensive than company B. Here's the key, less expensive. So on this graph, where is A cheaper than B? Well, right here at 1, who's cheaper? Isn't A cheaper at 1?
Yeah.
At 2, who's cheaper? Is A cheaper again?
Mm-hmm.
At 3, aren't they the same?
Mm-hmm.
At 4, who's cheaper?
A.
Isn't B all of a sudden cheaper?
Oh, yeah.
Isn't B below? Because remember, this is cost over here. So where is A less expensive? Wasn't it from 0 to 3?
Mm-hmm.
So if we look at this, which one of these answers says from 0 to 3 minutes? Can you see that C, isn't that saying from 0 to 3 minutes? This graph right here compares Earth to Moon. This is the weight on the Moon in pounds. This is the weight on Earth in pounds. So the question here, approximate weight on the Moon of an astronaut who weighs 120 pounds on Earth. So this is pounds on Earth. So it's 120, somewhere right around there.
Mm-hmm.
So if I went straight up, is that right about there?
Mm-hmm.
So on Earth, if I'm 120 pounds, I'm about right there. On the moon, how much do I weigh?
20 pounds.
20 pounds. So what's my answer? B. Again, this is your Earth weight, so you compare it to your moon weight. All right, you guys. Amy charges $30 per hour. Which graph represents the relationship between the number of hours and how much work, number of hours Amy works and the amount of money she charges for her work? Now, what this graph represents is she makes $30 no matter how long she works. That sucks. She could work 3 hours, $30. 5 hours, $30. 1 hour, $30. No hours, $30. That job either could really suck or be really good, depending on if it works 0 hours, $30. Yeah, baby, I got it. Okay, now look at this one. This one I made $150 no matter how long you work. Awesome. Could be. $150 no matter how many hours you work. Remember, this is hours. This is money. This one, isn't this after 1 hour, $50? After 2 hours, $100? After 3 hours, $150? But wasn't it supposed to be $30 an hour?
Yes.
Isn't this one, each hour, isn't she $30 more? After 3 hours, isn't 3 times 30 supposed to be $90? Isn't that about $90?
Yeah.
So your answer is C. All right, if I have x cubed times y cubed, doesn't cubed means times itself?
Yes.
So which of these has x times x times x and y times y times y? Right there. That's what it means, straight up. If I have x to the fifth and x is negative 2, what you have to realize is it's saying negative 2 to the fifth, which means negative 2 times negative 2 times negative 2 times negative 2 and times another negative 2. All right, fun. Let's multiply these two negative 2's. What do you get each?
4.
Won't that be 4 times 4 times negative 2?
Yes.
Now can I go, there's different things. Let's do these. What do you get? 16 times negative 2, and that would be negative 32. It's very easy to make the mistake. Here's some mistakes. First of all, you might just go, oh, negative 2 times 5, yay! No, that's not it. Some of you might forget it's actually negative and went for D. Some of you might have thought it was negative 2 and you put underneath, because don't negative powers go to the bottom?
Yeah.
But that's not it's a negative number, and it's a positive power. Negative powers do become fractions. Be careful of all these things. You guys, on this problem, what's equivalent to it? First thing you got to do is look very carefully and notice these are all, they're not all the same. First of all, hopefully you notice these ones right here are the same. This is different. So when things are the same and you're multiplying, doesn't this right here going to be a squared? Two things the same multiplied is squared. So isn't that going to be D here? Because you have this piece times itself and then this piece by itself multiplied. Now, if these are all minuses, if this was a minus right here, wouldn't this be the answer? If these are all pluses, wouldn't this be the answer? Just beware. When I square root this, you basically make it two separate square roots if you want. You can think of how you want, but it's also, it could be thought of as this. Okay, what's the square root of 4? 2. So cross that one out. And what's this one going to be? Well, hopefully you understand what squared gives you x to the fourth. It's x squared. Or do you guys remember you just half the power? Some of you remember you just half the power. So isn't it D? You could also think of what squared gives you x to the fourth, be x squared. And then this right here is 2. When you multiply these two, okay, you multiply the numbers in front. So 6 times 7 is 42. And then for the variables, you add the powers. So that's going to be 4 plus 1. This is going to be b to the 1 plus 3. And then this one would c to the first plus first. So you add the powers but multiply the numbers. And thus you get, which one of these? Would it be D? Okay. Now another way of doing it is, could you simply put 6, could you write 5 A's, a B and a C, times 7, 1 A, 3 B's and a C, and then look at them all, see how many A's, how many B's, how many C's, and so forth? You could write this out in a very long way that's kind of ugly, too. All right, when I'm multiplying these two, first thing you're going to do is multiply the 7's. So 7 times 7 is 49. So I could cross that off and that off. Then the a squared, does anything multiply by a squared? No, so it's a squared. Okay, the b's, I have 2 b's. What's b times b? That's b squared. And the c squared has nothing, right, to combine with. So do you see that answer? Isn't that c right there? Just be careful. If I want to find equivalence of this, equal thing, you want to break it up. This is the square root of 100 times the square root of a squared. What's the square root of 100? What times itself gives you 110? So can I cross off those two? And then what squared gives you a squared? Well, hopefully you understand that would be just a. So it's 10a, because a times itself is a squared. If I have this equation, if I have an x squared, you should know it's a parabola. So right off, can I cross that one out and that one out? Because these two are lines. X squareds do not make lines. The question is, which of these is the answer? Well, if the number in front is a positive, isn't it happy smile? It's a happy little guy. This is a sad. It'd be a negative something. So I know the answer is A, again, because it's a parabola, and it's a happy parabola because it's a positive number in front. If I have a cube is not a parabola. It's not a line, so I could cross this and this out. So it's one of these two. This is actually an absolute value. It makes a V shape. So all cubics have this format. Think of it as kind of like a parabola, but one of the sides got, it's kind of went down. They're kind of similar, it's just one half gets shot down. Anyways, that's what cubics look like. Cubics are third powers. So my answer is C. For this problem, if I have an x squared, I know it's a parabola, and since it's negative, it means it's upside down. So I can tell this is the answer. I know it's kind of hard to see, but this one right here is an upside down parabola. This is a cubic, a negative cubic. This is a positive cubic. This is a positive x squared. Your answer is the negative x squared. All right, for this one, you guys, best represents this graph. So are you okay that if you have an x, it's a line? This is a line going uphill. This is a line going downhill. And is this a line? That's a curve. So right off, could I cross off those two? My next question is, this is a squared, this is a squared. One's negative. Well, doesn't a squared make a parabola? And don't I see part of a parabola here? Isn't this part of a parabola? That part right there? And isn't that a happy parabola? So isn't the x squared positive? The negative would be a frowning parabola, half of a frowning parabola. So they just gave you half of the graph, so be careful. Now, this could also be a cubic graph, because the cubic would go like this and then back down. So for this problem, I want to find the slope. To find slope, I first must find 2 points. It doesn't matter which 2 points. I'm going to just take those 2 points. Any 2 points I could get, coordinates, nice, perfect coordinates. And what I do is I make a little right triangle. I need my rise over my run, that slope. So for this, do you see how I went up 1? And then I went over 2. You see I went up 1 over 2, so wouldn't that be up 1 over 2? The question, is it negative or positive? Well, do you know if it goes uphill, it's positive, and if it's going downhill, isn't it negative? And this one is going uphill, so it's positive. You have to rise over run, and it depending on going up or downhill. All right, you guys, if I have a slope of 2/3, I want to find d such that this line has a slope of 2/3. So a mathematical way of showing it is basically I want 2/3 to equal this over this. Don't you want rise over run? D over 6 to equal 2/3. So you have to think of, I want a fraction that will reduce to 2/3. And you look at the answers. Now some of you can look at that and go, oh, what would I need at 2/3? Wouldn't that be 4?
Yeah.
Isn't 4 6 going to be 2/3? That's one way. The other way that's a technical mathematical way of solving it is this. Just watch. You might not like this. Some of you just want to think, okay, 4 6 is equal to 2/3. But watch this. It's called a proportion. Do you remember doing something like that? You multiply those two. And then you multiply those two. And then you divide by the 3. That is the mathematical way of doing it. I would, if I was you, just kind of think, okay, what number divided by 6 would give me 2/3? I think that's easier, but this is called a proportion mathematical way. Now, for this one, I want the equation of the line. You need to know this formula, y equals mx plus b. What's m stand for? Slope. And what's b stand for? The y-intercept. So can you see the y-intercept right there? Which of these have a 3 for the y-intercept?
C.
Doesn't D have a -3?
Yeah.
So am I done? Do I even have to worry about slope?
No.
I don't have to worry about slope. That's the only one that has a y-intercept of 3. But let's check my slope. What is that slope? I went up 1 over 1, so that's m equals 1 over 1, which is?
1.
Is that a slope of 1 right there?
Yeah.
So yeah, it works. But technically you could stop at this point because you know your y-intercept is 3. If I want to find the slope of the line, I need to know rise over run. Do they give it to you?
Yeah.
Yeah, 2 and 3. That's your rise, that's your run. Now, if you did not give in those numbers, you'd have to do the math with these two coordinates and find out how far up and over you went. But they're giving you the rise and the run. So is this uphill or downhill?
Uphill.
It's uphill, so it'll be a positive. So since it's uphill, could I cross off those two? And which one is the rise over the run? C. Because the rise is this one, up and down, the run is side to side. I've never seen someone run up. You run side to side. Rise. Now, you guys, if Mario drives 1,400 miles per month, or every month, which correctly represents him. Now, is this the number of months? And this is miles. That's the same for each graph. Is it months by miles on all of them? So if he does 1,500 or 1,500 each month, so in 1 month, shouldn't he be at 1,500? Is that correct for number 1? For number 1, is he at 1,500 in 1 month? Yeah. How about for number 2? Where's he at after 1 month? Well, that's not 1,500. After 1 month, whoa, he's way the heck up here. That's more than 1,500 in 1 month, right?
Yeah.
Cross that out. Okay, oh, he's 1,500 the first month. But then what happens?
He stays the same.
Yeah, after 2 months, if he went per month, shouldn't he be at 3,000 the next month? This guy ran 1 month and never ran anymore. He said, I give up. He stopped, right? He never added anything else after, right at the beginning. He started off and never stopped. He started off with 1,500 and never did anymore. I quit, he said. So this is it, because this one represents every month you put another 1,500 on. Now for this one, the graph shows Francine's electric bill 4 different months. What is the price per kilowatt hour of Francine's electricity? So this is the number of kilowatts she used, and this is the cost. So in September, she used 200, and it cost her 30 bucks. In October, she cost her 45 bucks for 300, and so forth. So which month did she use the most electricity? Did she use the most in December? But all we have to worry about is one problem at a time. So let's focus just on this. If she did $30 in you have $30 and 200 kilowatts. It's $30. Keep saying it wrong. $30 divided by 200 kilowatts will give you your kilowatt per hour, your price per hour, per kilowatt hour. So the problem here is dividing and simplifying this. So you do this, cross that out, and then you have to do 3 divided by 20. When you do this, 1 goes into 20, that's 20. Minus, I have 10, bring down this. 5, 15 cents. It costs 15 cents per kilowatt hour. Meaning, if I multiply 200 times 15 cents, I will get 30. If I multiply 300 times 15 cents, I'll get 45 bucks. If I multiply 400 times 15 cents, I'll get 60 bucks. You can figure out how much you charge per kilowatt hour. A grocery sells 2 cans of soup for $1.50. If the relationship is graphed with the number of cans on the x-axis and the cost on the y-axis, what is the slope of the graph in dollars per can? Now you could do all this work and go, okay, this is my x-axis would be the cans, and this would be my cost. All right, but I think it's easier than that. Do you see this sentence, this statement right here? Dollars per cans. Dollars per cans. That's the key. I'm doing a fraction, dollars per cans. So what I need to do basically is get my $1.50 and for 2 cans. So how much is that per can? Well, divide it. What's $1.50 divided by 2? Can you see it's 75 cents? So it's 75 cents dollars per cans. Dollars over cans. All right, this inequality, represents, or X represents the salary of an employee. Which phrase most accurately describes employee's salary? So basically you solve this. So first thing you do is minus the 10,000 over. So I got 2x is greater than or equal to 60,000. And then you divide by 2. X is greater than or equal to 30,000. Now, look at the answers. Are they all 30,000?
Yeah.
So that really doesn't help me with the 30,000. The question is greater than or equal to. My first reaction is to think, oh, yeah, more than 30,000, right? Now, more than 30,000, be careful with that. This is more than 30,000. Okay, this is more than 30,000. But I have this little sign underneath, don't I? So that's not it. Isn't it more than or equal to 30,000? So is it less than 30,000? No. Now here's where it gets confusing. Here's what I got to think about. Ready? This is saying at least 30,000. The lowest amount could be 30,000. Isn't that what it means? It has to be larger than 30, so the lowest it could be is 30,000. I know it's backwards thinking, but the answer is A. Because the lowest it could be is 30,000, but it is bigger than that. Isn't that confusing? The at least is a greater than. At most is a less than or equal to. Tricky. Very, very tricky how it's worded. Again, if it was just greater than, it would be D, but it's not. Now, in order to solve this, the first way I would think about is just to add 3 over. And you get, ooh, that's ugly. Okay, and then you divide by 2. X is 5. There's your answer. Now, the other way to do it, you guys, is to slowly take answers and plug them in. So let's take 5 and plug it in. 2 times 5 minus 3 equals 7. Doesn't that equal 10 minus 3 equals 7? Is that true? Mm-hmm. So, wouldn't all of these be wrong if I plugged them in?
Yeah.
So if you wanted to plug answers in, you could just plug all of them in and see which one comes out true. Or you can solve it, whatever's your best strategy. In order to solve this inequality, you first want to just get n by itself. So you minus the 3 over. 2n is less than 14. And then we divide by 2. N is less than 7. Is that a choice?
Yeah.
There it is. Now, if you were to divide by negative 2, this sign would flip. But we don't have to worry about it on this problem. You simply solve and you're good to go. Remember, this is a less than sign. Now, the owner of an apple orchard, okay, there's boxes that weigh 2 kilograms, empty. Apples average 0.25 kilograms, so a quarter of a kilogram. And the whole box and everything with the apples in it should be 12 kilograms. How many are packaged in each box? How many apples are there? Well, the best way to think of this is to look at the answers and work backwards. Now, do you guys understand if it's 2 kilograms for the box and the whole thing with all the apples is 12 kilograms, right off the bat, can I just go like that and get, well, I need 10 kilograms of apples by himself? You got that? Because if I have 10 kilograms worth of box, the material of the box, and the whole thing's 12, doesn't that mean the apples by themselves are the 10 kilograms left over? So how many apples would give you 10 kilograms? So let's try answers one by one. Let's go 0.25 times 14. When I do that, I get 20. Okay, that's 7, put a 0. 2 times 4 is 8. 2 times 1 is 2. Does that equal 0? That's 3.5. Is that 10? Let's go to the next one, 40. Can I go 40 times 0.25? Put the 0 because it doesn't matter. Put a 0. 4 times 5 is 0. Put a 2. That's 8 plus 2 is 10. Okay. Put the decimal there. Is that 10? There it is. So what I did again is I noticed that 40 times 0.25 kilograms each would give you 10 kilograms, plus the box would be 12 kilograms. You work backwards. You simply try this into the problem and see which one works. We can stop. We got it. You got to really watch out for this initial weight of the box. It's kind of mean. For this problem, you guys, if the bought a binder for $6, he only buys one binder, and he bought packages of paper for 60 cents each, and his whole cost was $13.20, ignoring tax. How many packages of paper did he buy? Well, if you go one by one through the answer, let's look at 2. What is 2 times 60 cents? Wouldn't that be $1.20? Plus, wouldn't there be a $6 binder? Isn't it $7.20? Don't I want that much? Could I cross that out? Okay, let's try 6. What's 6 times 60 cents? Well, you notice that's $3.60. Plus the $6. Does that give us enough money? Does that give us that much? No, that's $9.60. So we could cross that out. Go to the next one. What's 12 times 60 cents? What you should get with that is $7.20. And then plus the $6. Did that give me $13.20? Bam. If one by one you just kind of multiplied it through, you'll get to the answer. Now for this problem, you have this 54-inch pipe, and you have these 2 pieces, and you want to find x, and you need that right there. Now you could technically, do you understand you are technically making an equation that 2x plus 26 equals the whole 54? Could you make that equation and solve it? Did anybody try it that way? You could, and you could try to solve that. Now, I think easier, could you just look at x right here and plug in that number? What's 2 times 3? And what's 6 then plus 26? Isn't that 32? Does that equal 54? Could cross it out. Now can I go, okay, 2 times 14, that gives you 28, plus the 26, does that equal 54? Good, there's your answer. If you go one by one, if you just simply plug in for x these answers, multiply it, then add 26, you're looking for 54. You could also solve this. Got it? Minus the 26 over, divide by 2. Alright, you guys. Stephanie read 456-page book. Alright? During the past several days, she read 168 pages in 7 days, basically a week. if she continues reading at that same rate, how many more days will it take for her to complete the book? All right, so I want to know how long it will take her to complete the book. Now, what you need to understand is this is a proportion. It's number of pages per days. So let's make a proportion here. Do you understand? I have 168 pages in 7 days. That's a given fraction, I can tell. But don't I want 456 pages? So don't I want this to actually be 456 pages? Got it? Now there's going to be a little change I have to do after that, but watch this. This is called a proportion. So I can cross multiply and solve. I get 168x equals, dang, that's a big number, huh? 7 times 456. Okay, that's 2, 4, 7 times 5, 9, 3, 4 times 7, 28 plus 1, 31. Nice big numbers, huh? Then you got to divide by 168. Okay, so if I pull out a calculator, which you can on the CAHSEE, but if you took the time to divide that, that's going to take us a while, isn't it? Now, when you do that, you get x equals 19. That's not my answer, though.
Oh, that's right.
Now, that's not my answer. Here's the trick. You ready? Again, that is an ugly division, but you could do it with some time. It's annoying. I really wonder why they give you such big numbers sometimes. Now, watch this. That is for the whole book. Look at the question. How many more days? Didn't she already read for 7 days? Got it? So isn't it really 19 minus 7? So isn't it 12? Isn't that tricky? How many more days? Since you already read 7 and it's 19 for the whole book, shouldn't you minus the 7 and get 12 altogether more days? Aren't they mean? You do all this work and then you do all this work and you go for 19. It's like, oh, crud. It was 12 because how many more stinking more days, you little stinker? Now, if toy car travels, that is a really big thing, pointer. 40 centimeters per hour, okay, high speed and 15 low speed. If the car travels 15 seconds at high speed and 30 seconds at low speed, what's the distance? So here's how it goes. First thing you do, if this is at high speed and you went for 15 seconds, watch this. If you went 15 seconds and you went 40 per second, that is simply 40 times 15. Got it? Because you went 40 centimeters per second and you went 15 seconds, you just multiply them. So that'd be 0, that'd be 20, put a 0, and that'd be 40, so that's 600. So you went 600 to start with. Then you have 15 centimeters per second at low speed, but you went for 30 seconds. So you do 30 times 15. 5 times 0 is 0, that's 15. 0, 1 times 0 is 0. 3, that's 450. Now, aren't these add them together? There's my answer. Because 40 centimeters per second, and you went 15 seconds, so you just multiply 40 times 15. And in this, you multiply that times that, you add these together, and you get your answer. All right, Sarah can ride her bicycle 3 miles in 15 minutes. How many miles can she ride her bicycle in 50 minutes? So, you should notice that you have miles and minutes. So we're going to do miles per minute. So we have 3 miles in 15 minutes. We know that. Now, 50 is my other number. Is that going to be in the minutes or the miles? Isn't that a minute? So wouldn't it be on the bottom? And don't we want to find how many miles that would be? So could you cross multiply and solve? Okay, 15 times x is 15x. 3 times 50 is 150. divide by 15, x equals 10. Now, is that exactly it? Yeah, we don't have to worry about subtracting or changing anything because 50 minutes is what we want, and it would be 10 miles. All right, if Lisa typed a 1,000-word essay at an average rate of 20 words per minute, she started at this time and not take any breaks, at what time will she finish typing? So the first question is, here's my rate. So aren't we doing words per minute? So if I set up a proportion, isn't that 20 words in 1 minute? Words per minute, per 1 minute. And don't I want 1,000 words? Isn't this 1,000 words? So isn't words the top? Don't I want to know how many minutes it would take? And then we cross multiply. 20x equals 1,000 when you multiply across. If you divide by 20, okay, that cancels, and you get 100 divided by 2, x equals 50. Wait, 50 is not a choice. Well, what's 50 minutes more than this? Wouldn't 40 minutes make that 7? Plus another 10 minutes, isn't it right there? Yeah. Isn't that 50 minutes more than my initial time? Yeah. Again, this was words per minute, so I needed my words, and I need to find how many minutes it would take. It is kind of tricky. That's 20 words per minute. You have to realize that's a 1 down there.